speaker. His name is Oliver Bründler. He's been working with FPGA for an extended amount of time, almost 20 years now, since basically he started his higher education studies. He worked at PSI and with Enclastra, and also teaches related courses at the University of Applied Sciences, Northwest Switzerland. So since he observed that the FPGA world was lacking a good standard library, he tackled this topic in his spare time originally, and then about a year ago, he published OpenLogic, a library of reusable, modular, and vendor-independent components.
So welcome everybody. I will hold a talk about OpenLogic, the open source FPGA standard library I'm working on for quite a while now. What will we be talking about today? First, we talk about what OpenLogic is, what you can expect from it. Then we talk about my motivation. Why do I do that? Why do I invest my time into it? Why you should be using OpenLogic, what the benefits for you are. Then I give you a brief overview over the content. And then last, call to action. Of course, I show you how you can get started, right? So first of all, what is OpenLogic? OpenLogic aims to be for HDL developers what standardlib is for C, C++ developers. So it provides reusable basic elements like clock domain crossings, FIFOs, width converters, delay lines, content addressable memories, often used interfaces like SPI, I2C, AXI, kind of all those basic elements that you use from day to day, you shouldn't have to develop them. They should be provided somewhere, right? OpenLogic might grow into other areas like fixed point mathematics, DSP, video, networking in future, but always with the mindset of providing basic blocks, not complete applications or the likes. A question I'm often asked is like, how does OpenLogic compare to OpenCores? Well, first of all, OpenLogic is alive. That's probably the biggest difference. Second, OpenCores always provided full IP cores and from different people, different developers, and let's say mixed quality levels. OpenLogic is one library. It's always the same quality level for everything, and it's not providing applications. It's providing basic blocks that help you developing the application. So it's one layer below. If we come to software development analogy, OpenLogic is more a standard library. OpenCores was more something like an application store. OpenLogic is built from a user's perspective. As you heard, I'm working since kind of 20 years or the likes in FPGA, and I have been a user for that time, and I have seen so many things that I disliked that I think I have some kind of user's perspective on the whole topic. So first of all, I focused on documentation, because any code that is open sourced without proper documentation is, in my opinion, unusable. Then I added metrics for code quality. For every piece in OpenLogic, you have metrics that say you how the statement coverage and branch coverage looks in simulation, and if there are any open issues in GitHub, so that you know whether you can trust that piece of code or not. Kind of a small spoiler, you can trust it, it's all 100% covered at the moment. But you have that live indicators that would indicate if coverage is bad or becomes bad over a lifetime somewhere. It comes with tutorials. I have seen too many pieces of open source that are just a bunch of code and you have no clue how to use it. OpenLogic provides tutorials telling you how to use the code, how to integrate it in your tool step by step easily. It provides tool integration, so you don't have to ask yourself about what files are needed, where they are, what's the compile order. You execute one script, and all the files are just there, usable in all the commonly used tools. And you get the mood. Wherever I focus on simplicity and ease of use. If you don't need a certain parameter, it will have a default value. Just omit it in the instantiation, it will be fine. If you don't need back pressure, just omit the ready signal. It has a default value that it doesn't have any impact in that case. So wherever possible, you can go the easy path. License-wise, always an important topic for OpenLogic, for open source projects. OpenLogic is under the PSI HDL license. That's a modified LGPL license with a small annex that explicitly allows you to deliver bit streams, to deliver hardware with bit streams on it under your own terms. So OpenLogic is published with the mindset that you can use it in industrial projects without any copyleft to your code. The only important restriction is that you have to publish changes to OpenLogic itself, but you don't have to publish your code. About the philosophy of OpenLogic. First of all, OpenLogic is pure HDL code. This means it compiles to any device out now and any device in future. That's very important because it means implicitly you can compile the code to new devices and you don't have to wait for them to be supported or the likes. Currently, I explicitly support AMD, Altera, Microchip, Efinix, and GoWin, and they come with tutorials and the likes. But because the code is HDL, it also works for any other vendor, just that probably one or the other pragma for optimization reasons would not be there. But generally, HDL will work for all of them. OpenLogic is written in VHDL, but there is a clear commitment to make it usable from Verilog. This means on all interfaces, only types are used that are also accessible from Verilog. For all the tools listed here, there are Verilog examples available. So even if you are a Verilogger, you can use it. Then trustability of code. As you got the mood, right? Trustability is a key for me. So we have a proper CI setup that runs simulation and linting in the cloud, synthesis being coming soon. We have 100% statement branch coverage on all the code in there. There is the issue indicator I'll show to you. So the general idea is that you have code that you can trust and you know you can trust, you can use without having fear of it. And of course, free tooling. It's an open source project. Everybody should be able to contribute independently of what licenses you have. So OpenLogic, of course, you can use the paid tools, right? But you can execute all tasks from linting through simulation, all with free tools, so you can work at zero cost on the project if you want to contribute something. Now, what is my motivation? Obviously, it was a bit of work of pulling the whole thing up. Why did I do so? First of all, I'm an FPGA nerd. I got into touch with the technology and I fell in love. I just want to tear down all the barriers that keep people away from the technology, to make it accessible, to make it usable. That's something I personally want to work on. So it's kind of a hobby project I really like for me. Then I'm teaching. And I told my students so many times, don't write your own clock crossings, don't write your own FIFOs. And then they asked, what should I use instead? And I was like, yeah, not something from the vendors that will lock you in. And they were like, yeah, what then? And I couldn't point them to a good location. So from that perspective, I wanted to do something to point them to, right, to solve this problem. And last but not least, I didn't find a unicorn. Well, what does it mean? I was looking for that unicorn library, the one that has good quality, good documentation, works for all the vendors. That was my unicorn. I looked for it. I spent time searching for it, but I really didn't find that unicorn. And I really looked for it. You see here a bunch of libraries I looked at, and I checked whether they solve my problems. And these are all great libraries. Don't get me wrong. They are good sources of code. But no single one of those provides the quality levels I want, vendor independence, documentation, and the public CI/CD run. I don't say these are all bad quality. Some are really high quality. Some are kind of medium. But none of them has all the points that I personally find important. I include the links to all of them in the README of OpenLogic because I think like if they solve your problem, use them. I mean, I don't think open source libraries should compete and fight against each other. The goal is that users should be able to solve their problem. And if I can contribute something, I'm happy. But if you find your solution in another library and I pointed you there, I'm happy as well. So you will find those links. If you miss some functionality in OpenLogic, look it up there. Use it from there if you find it's good quality and you can use it. So these are valuable sources, but not the solution for my problem. I also ask myself, does the world want OpenLogic, another HDL library? Really? Well, my plan was small. I did that little thing for my students, and I published it. I think the first LinkedIn post was roughly a year ago, a few weeks before my second daughter was born, and I didn't look at LinkedIn for a while, and then I opened LinkedIn again, and I knew the world wants OpenLogic. It's you guys that made it big. I didn't have that big plans, but what happened during the last year is the thing here. OpenLogic is the last of the libraries that that was founded, and you see like how the number of GitHub stars just went up. So obviously it hit some nerve. There obviously is a need if people jump on the train so quickly. So I changed my plans and I took the challenge and said like, yeah, let's make it a bit bigger than I thought it would end. And since then it was sometimes challenging, but also joyful ride. So why should you be using OpenLogic? What are the benefits? Well, let's ask another question. If you are programming C, C++, why are you using the standard library? You don't want to waste time on code that already exists. In C++, you don't want to write dictionaries, and in Logic, you don't want to write clock crossings, right? You also don't want the risks of debugging your own CDCs and FIFOs and the likes. You want to spend your time on the application. You will not write a better FIFO than anybody else, but you will write a better application because you know your application. At CERN, you know kind of the time sensitivity that you have or the bandwidth bottlenecks. That's something you know, and you can invest your time in writing FIFOs. Anybody can do that. And last but not least, why not? It's free. Try it out. If you are happy with it, keep it. If you are not happy with it, drop it. It doesn't cost you a single dollar. OpenLogic will lead to better quality by means of portable code. It means like you can port it to other devices, other projects and the likes. And this also means you can move along with technology. We have heard in the presentation before that with HBM memories, the life cycles are much shorter, and this is a problem. Well, if your code is portable, it still can be a problem, but it's the smaller problem. If you work on RFSOC projects, the devices come out in rapid succession there. If a newer device comes out with a better ADC that matches your needs, you want to be able to pick that device, to use that technology. And for this, you need portable code, probably also portable between vendors. It means you can choose the best fitting device, which will, in the end, improve the quality of your application. OpenLogic also basically makes code more reusable. It also makes your code more reusable because you don't have any hard-coded vendor macros in there. Yeah, all the OpenLogic blocks are configurable. That gives you just a bit more options to make more code reuse. And also important, in my opinion, if we create portable code as developers, we will reward vendors that are innovative. We will pick the coolest and best device for our application, and these devices get the socket they deserve. All the vendors, they create really cool stuff. It's, in my opinion, a pity if we cannot switch to the best device just because we are locked in with some vendor macros. We should be free, and this would also lead to the vendors being rewarded for good quality, good support, good devices, whatever they do good. Of course, OpenLogic reduces cost. Development cost is an obvious one. Maintenance cost as well, because if you have to change the device, it just works a bit easier. Then there is a risk factor. As I said, FIFO, CDCs, they all have a risk. You don't want to have that. That's the obvious one, which is a bit less obvious one is the second sourcing. With portable code, you can use any FPGA from any vendor as a second source. I mean, you have to redesign your hardware. That's not for free. But often, that is at least a viable option or better than no option for second source. We have seen supply chain problems in the past years. We all know that FPGA suddenly got by a factor of 20 more expensive or not available at all. We are facing trade restrictions at the moment. Who knows which FPGAs we get or at what price in 2-3 years. So it probably could be good if we are flexible to target any FPGA, right, with our code. And of course, end of life. We also have heard that in the presentation before around HBM memories. If our code is portable, end of life is a smaller problem. It's still a problem. We still have to change hardware and the likes, but it's the smaller problem. Good. So far about what OpenLogic is, motivation, and why you should use it. We now will look what's all in there. Before I guide you through the repository, OpenLogic is split into areas, I call them. Base is basic functionality, then we have interfaces, we have one for AXI, one for fixed point will be coming soon, so the number of areas will be growing, but the code is organized in those areas. And each component you find as code comes with documentation and also with a vUnit test bench that does verification. Good. We do a little live tour. So you find OpenLogic through Google, GitHub OpenLogic, you will find the repo. It's pretty obvious, right? We start on the README page, which basically explains most of the things that we discussed today, philosophy and the likes. You can also find the links to the other libraries down here. You also find possibility to sponsor the project, which I, of course, appreciate. There are some running costs, and really kind of, if you pay $2 a month, it makes a change if a few people do that. The running costs are not super high, every dollar counts, so I appreciate any small donations. I said that tutorials are important to me. You find them here. So, for example, if you are a Vivado user, you go here, you get explained how you build a little project with OpenLogic inside, how you compile it, you can download it to hardware and try it out. So it comes with a full tutorial for all the tools that are officially supported. Then the how-to section is one that is important. Whenever you ask yourself, how can I? Go here. It tells you how you integrate OpenLogic in all possible projects. It also tells you how to integrate it through ViewSock, the open source package manager if you use it. It also tells you how to run simulations, how to run the linter and so on, how to integrate it into VS Code. So all the important topics for you as developers are covered here. And then, of course, we have the entity list that tells you what's all in there. We quickly go through it, really quickly. I don't want to spend too much time here. There are a bunch of packages, utility functions. Few things are in VHDL 2008 already covered. OpenLogic is still not 2008, not fully, because not all tools support it. So I stay better on what all the tools support instead of being new and fancy, right? That means we need a few more packages for utility functions. Then we have a bunch of clock crossings for different needs. I don't go into any details here. There is a video on YouTube. There is an OpenLogic YouTube channel. There is a video about clock crossings. If you want to know more, I suggest you watch that video instead of making the presentation long. Then we have RAM implementations that fit to all vendors. FIFO implementations, sync and async FIFO, and also a packet FIFO that allows dropping and repeating packets. We have width converters with integer ratios, but also non-integer ratios, so you can convert 32-bit words to 7-bit words or the likes. We have arbiters, time division multiplex handling, and miscellaneous, that's a big category. Pipeline stages, including back pressure. We have fixed and configurable delay lines, dynamic shifting, which is timing optimized, pseudo-random binary sequences, event handling like strobe generation, strobe division, reset generators, content addressable memory, that's an interesting one, a flow control handler that allows you to add back pressure to blocks that natively don't support back pressure, a first bit decoder, CRC. Then we have the AXI area, where we have surprisingly little things, right? Only a pipeline stage, a slave, which allows you to easily write your AXI register banks, and two masters. The simple one only allowing aligned accesses, and the full one also allowing non-aligned transfers. Why do you only see those four blocks here in that area? Well, I saw that there are two libraries out there that do a very good job in providing, it's around here, that do a very good job in providing AXI infrastructure for interconnects. So I decided to not invest effort into that. Better go there. It's already solved. And OpenLogic focuses on AXI as you need it in the endpoint. So if you write your own IP, you either need AXI masters or AXI slaves, but you are less commonly in the situation where you need, let's say, crossbars or the likes. And then we have the interfaces, synchronizer, I2C master, SPI master slave, UART, debounce, and clock measurement, where you can measure the frequency of a clock. So it's all not rocket science. It's all basic blocks that simplify your daily life. And as said, fixed point mathematics will be added soon, which probably opens a few more doors into signal processing and the likes. Good. From here on, we jump back to the slideshow. So, call to action. What's next for you? Of course, start using OpenLogic. Get it from GitHub. You can download it as a zip. You can clone it through Git. All the options are possible there. If you are a user of FuseSock, OpenLogic is fully integrated. It's also part of the FuseSock standard core libraries, so you also get it through there easily. Core files are in there. Inform yourself. There is documentation on GitHub I have shown you. Just browse through. You will find things. Oh, I missed some point. I will do it in the very end. Then go to the YouTube channel. There are currently only 3 videos, but 1 or 2 will be added in future. It's a good point to start. It's always easy to watch a video to get started. Then help me spreading the word. Let your friends know. Post on LinkedIn. Repost my posts. I also appreciate if you post to other networks. I'm more active on LinkedIn, but if somebody of you is kind of a guy that's active on X or that likes to do TikTok about FPGAs, I'm very happy if you do something out there. Those are channels I don't reach myself. If anybody helps me here, I'm very much a fan of it. Give it a star on GitHub. That's also kind of the number of stars there gives the project some visibility. Then contribute. It doesn't mean like you have to write code. If you just report a bug, if you ask for a feature, if you fix some typos in the documentation, those are valuable contributions. They help to improve quality. Even if you just tell me like the figure there is wrong or misleading, that's important for other users. So please just let me know. I take that seriously. If you want to contribute code, I'm very happy. I mean, it's an open source project. I'm trying to build up some kind of a core team maintaining the project. Not only me, but shared through people. Just contact me on LinkedIn or through GitHub or by whatever means you find. I will try to help you, guide you through so that you can contribute. Then, of course, money is a topic. There is some running cost. I invest a lot of time for free. I would be happy if I don't have to invest money. You can sponsor the project through GitHub sponsors. For the ones that work for companies that don't like to donate, you can also buy things there. You can buy priority support or an introduction workshop. So if your boss says, I don't do donations, and you still want to support me, go to your boss and say, like, I want to buy priority support or a workshop. That's something you can buy and you can pay for. You still help the project. You get something in return. And there is a GoFundMe campaign for a dedicated GitHub runner to bring synthesis to the continuous integration flow. It's by today morning almost met. I need 3,000 francs. We are at 2,830 or the likes. If you want to make my day very great, make it happen that the last $170 arrive by today evening, and I will have a big smile in my face. So that would also be an option how you can donate. What's next? You can expect fixed point mathematics to come very soon in the coming weeks. And a few kudos to vUnit, the verification framework I'm using, GHDL and NVC, the 2 open source simulators. Without those, it wouldn't be possible to pull up an open source project. Same for VSG, the free linter, which I use, also very important. And Wavedrum, in my opinion, a tool that can't be missed enough in documentation. I use it for all the figures, so it's really a great tool. We would now be open for questions, but I noticed that I missed one point in the repo tour, so I do that before we go to the questions. Of course, I should show you how documentation of a block looks. If I already say documentation, always say documentation is important. That's how it looks. You have a link to the source code, of course, kind of where you can see how the code of the block looks. You have the quality indicators. You always have a description what the block does, also with timing diagrams and the like, so you understand what it does and how it works. It has a description of all the generics and interfaces, and where it makes sense, there is an architectural description. I mean, architectural description doesn't always make sense. If a block is super simple, it's omitted. But for significant blocks, it's all there. So I really try to keep the documentation up so that you know what the thing you're going to using is and how you have to use it. Good. That's it. I would now be open for questions.
Thank you very much, Oliver. Let's turn to the audience. I'm sure a lot of us will find this useful in our everyday work. So if you have any questions, please feel free to press the unmute button and go on.
Hi, so thank you for such an excellent presentation. I was wondering, you mentioned a couple of FPGA vendors of the devices you support. What about Acronix?
What about Acronix? I asked them for a dev kit. I mean, as it's a hobby project and the currently ongoing funding is the first funding round I'm doing, I was operating on my cost up to now. So I asked the vendors to provide free kits. I had an Altera and an AMD kit already at home. Those I didn't have to ask. The other ones, they all provided a free kit to me. So I could build up the reference designs and try it out. Acronix I asked, but they, I think, need some paperwork and some NDA that you get their tools, and they don't want to give it to private persons, as it looks, and their kits cost too much for a donation to kind of use it. So that's why it's not there. I would be very much in to do that, but I would need some hardware to officially say it's supported. Supported means there is a tutorial, there is tool integration, and it's tested on hardware. At least the reference design with the few blocks that it roughly works. For Acronix, I can't do that because I don't have the tool and the hardware, but the code will work. It's written generically enough, and if you have Acronix and you have the tool on your end and you have trouble with, I don't know, RAM inference probably is the most tricky part. If that doesn't work, we can communicate and find a solution. But I can't officially support it because of the missing tools and hardware.
Thank you.
We have one question, too.
Hi. So thank you for this very interesting presentation. I was wondering, you mentioned you're using vUnit for verification. Is that correct?
Sorry?
You mentioned you're using vUnit
Yes.
for verification?
Yes, I'm using vUnit for verification, so all the test benches are vUnit test benches, and all the simulations are vUnit. You find more details in the documentation. Personally, I find it a great tool, and also where needed, I have some verification components in, especially when we come to fixed point in the coming weeks. I didn't make it before the presentation. There will also be, in fixed point, the testing between simulations in Python, and the VHDL world is super important, and there will also be vUnit components provided to do that interface and the likes, and of course a tutorial for it. So vUnit is all the way maintained. It's not like officially advertised as something that the verification components are something you can use, but of course you can use them. They are all there. Yeah, just pick them.
Great, thank you.
So vUnit automatically extracts the compile order usually.
Yeah,
We cannot hear very well.
Okay. Better? Yeah.
Yes.
So vUnit extracts the compile order automatically, usually.
Yes.
And sometimes there are existing projects that have an existing Tcl-based build system. Is there some method is there some list of the compile order or something, some easy way to include the library into an existing Tcl-based build system or simulation?
I mean, you are not forced to use vUnit at all. It's just like the framework I use for development of the library. There is also a bare Questa tutorial provided, where the files are just vcom compilated, and you can run it in Questa. You can also just import the files separately into your project, so you are not bound to vUnit in any ways. It's just the tool that I use to execute my work. But on your end, you can happily use any other tool for verification or your own compile scripts or whatever you like.
Yeah, so if there's a custom compile toolchain, you usually have to extract the compile order yourself. And it would be great if there's a list of the files in the correct compile order that you can go through. Because that's what many frameworks are missing.
It's not yet there, but I think it should be pretty easy to generate it out of vUnit. I take a note.
Yes, it is. So you can, but maybe that's a thing that many open source frameworks and so on are missing. So a standardized method of defining the compile order. Because if you don't use vUnit, you have to do it on your own.
Yes. So I will try to add a list of all the files in correct order, so you could pick that. Thank you for the input.
We have another question here.
Hi. Whilst I understand the need for backwards compatibility in these kind of libraries, do you not feel that we should really be pushing towards making as much use of VHDL 2019 or at least 2008 in these kind of things, so that vendors then are pressured to support it as much as possible?
I didn't get you acoustically. Could you repeat?
Basically, do you intend to use as many VHDL 2019 or VHDL 2008 properties or features in the future to try and put pressure on vendors to support them, given that you have a relatively good standing?
You know, I work for long enough in the business that I know that you know, putting pressure on the vendors. If I, as an open source guy, say like, hey, your tool doesn't support 2008, they say like, yeah, even better, right? Then people use our block RAM primitives and they are locked in. It won't work that way. So I think like my approach to it is using what all the vendors use, so making sure that all the supported vendors, the code really compiles, which means sometimes staying back. It's mostly 93 VHDL. I would better like to put the pressure to the vendors or give them the chance. I mean, it has two sides, by motivating people to write portable code. Because if people write portable code, and OpenLogic is one part of it, but of course it needs more for that. Vendors will have to provide better service, good devices, good support, probably also VHDL 2008 support, to motivate you using their device. The easier you can switch, the more pressure there is to be innovative, to be up to date. And as I even mentioned it in the presentation, I personally would find it fair if the landscape becomes more open, so that if a vendor provides good support, a cool new device, that he really gets the sockets. And it's not like all the people say like, yeah, it's a cool device, but I'm locked in with some primitives of another vendor. So I'm more coming from that side, and I wouldn't want to use too much VHDL 2008 and then stand here and say like, hey guys, but it only works for AMD. I think that would break the idea of the library. But I get your point. I'm also a bit unhappy on that side.
Thank you very much.
Okay, so we have one last question from the Discord forum.
There is a question from home, from Nico. How are vendor-specific components handled by OpenLogic library?
I rely strictly on inference. So it's really all HDL and written in a way that synthesis tools understand it, and I run it through all the tools, and I invested into building infrastructure to easily run my code through all the synthesis engines, so I can compare if they all synthesize correctly. That was a topic which held me busy around February, because there was a question about, I think it was byte enable, RAM initialization. And I then, with RAM initialization, fell into a rabbit hole that I found out that Quartus Prime Pro, not the standard, Quartus Prime Pro only did have problems with RAM inference. No, it was the other way around. Quartus Prime Standard has problems with RAM inference with byte enables. So I invested into infrastructure to clean that up. And that's also the path I want to follow, to really strictly rely on inference and test the things. That's also why I need the GitHub runner to push that a bit further, because that's the only way how we can keep the code really portable also to future devices.
Okay, we have to move forward. One more?
Maybe quick, just a curiosity, if you had the chance to talk with the other, let's say, developers of other similar libraries to make an effort to combine to a similar?
I'm in contact with many of them. If you, for example, HDL modules, Lukas Wick, who was here last year, I'm in contact with him. That's also a reason why I say I don't dig into Axie infrastructure. I think Lukas did a great job here. I not 100% agree because his code is kind of AMD tailored. That's not my mindset, but for AMD it's really great code, and I fully agree on quality levels there. So we discussed, like, where are you going, where am I going? We shouldn't do the same thing. And he said, like, I'm staying with more interconnect infrastructure thingies, probably doing a few clock crossing in future. So I said I go to the node. So we didn't combine, but we split the topic so that we together cover as much of the landscape as possible. And I'm also in close collaboration with Patrick Lehmann, who does the pile of cores library, which is probably a bit more similar. It was long unmaintained and now became maintained again. So there is a bit more overlap. I don't see that they will be combined for several reasons, but again, we are in touch, and whenever we see the possibility, we try to cover different areas.
And that's very nice to hear. Okay, let's thank Oliver again.
And for further questions, you are very welcome to just pick me up in the next break, right? I'm still here. I'm only here today, but I'm here today until the evening, so you can ask more questions if you want.